Welcome to the course Cambridge International S Level Chemistry. In this course, now I want to discuss about the chapter Halogenoalkanes. This methane. If this hydrogen is replaced by chlorine, the compound will be Cl. This is halogenoalkane. These halogenoalkanes we can express by general term Rx. R is here alkyl group. R can be CH3, C2H5, C3H7, so on. And the X can be chlorine, bromine, iodine. Halogenoalkanes are three types. They are primary, secondary and tertiary. The primary halogenoalkane, carbon having halogen, any halogen, chlorine, bromine or iodine, it has one R and two X. Carbon having halogen, it has two R and one hydrogen. Tertiary halogenoalkane, carbon having halogen, it has three R. R can be same or different. R is here alkyl group, I already told. This can be C3H7, C2H5, CH3, like that. And halogen means here chlorine, bromine and iodine. Bond polarity of halogenoalkane. Carbon, it has F, fluorine. These all can be hydrogen or any alkyl group. And this one carbon, chlorine, carbon with bromine, then carbon with iodine. Here the difference of electronegativity, this is greatest, this is the least, so almost this is non-polar, and this is the polarity highest, most polar. So polarity decreases from left to right because of the difference of electronegativity in carbon fluorine is the highest. Difference of electronegativity, carbon iodine is the least, so that this is almost non-polar. Now nucleophiles. The nucleophiles are here the species having lone pair electron. These can be two types. Number one, partially negative and absolutely negative. Let us see. OH minus 6 electron. This is absolutely minus. Then NH3, it has lone pair. Nitrogen here partially minus and hydrogen is partially plus. This is also nucleophile. H2O also nucleophile. Then CN minus, this is also nucleophile. These all are nucleophile because of they have lone pair. This is negative, absolutely negative. This is also absolutely negative. But ammonia and water are partially negative because they have the lone pair. They don't have the negative charge, but they have the lone pair electron. So these are nucleophile. We need this basic in this chapter. This nucleophile can replace halogen in the halogenoalkane. Now, reactions of halogenoalkanes. Halogenoalkanes have two types of reactions. Number one, nucleophilic substitution, and number two is the elimination reaction. Nucleophilic substitution reaction with water, with alkali or NaOH, with ammonia and with KCN. This is halogenoalkane. The beer can be replaced by OH present in water. OH is coming from water, so here the products are OH and beer minus. This is nucleophilic reaction. This reaction is very slow reaction. No more addition is needed. Now another reaction, C2H5Br plus KOH or NaOH, dilute KOH or NaH. This reaction, heat is needed. In this reaction, this beer will be replaced by OH. OH is the nucleophile, so the products are C2 H5OH ethanol plus KBr. Now another reaction, C2H5, the same halogenoalkane we are using, plus NH3 gas. In this reaction, pressure, high pressure is needed, temperature is needed. Also ethanol can be the solvent. Ethanol is the solvent because otherwise if we use water as the solvent, it ammonia will be dissolved. So the product are C2H5NH2. This is primary amine plus HBr. This is the steamy acidic fume is the product. Another reaction, we are using halogenoalkane, bromoethane plus KCN. KCN here ethanol is the solvent. And high temperature is needed in this reaction. The CN will replace Br. So the product is C2H5CN plus KBr. In this reaction, this is called nitrile compound, propane nitrile. In this reaction, the carbon number has increased, so this is called chain elongation reaction. Carbon number increases. This is only the reactions of halogenoalkane where the carbon number increases. Bromoethane to propane nitrile, one carbon increases. CN is here nucleophile, it has replaced Br, so one carbon increases. Another reaction of halogenoalkane is elimination reaction. In this elimination reaction, this is halogenoalkane with any alkali KOH, strong alkali, it should be concentrated. Then heat is needed. And ethanol is the solvent. This reaction can also be substitution if the conditions are different. Here Br from this carbon and H from here are replaced. So the products are CH3, then CH double bond. Propene is the product. From here. Now mechanism of nucleophilic substitution reactions, that is SN. This is two types. The first one is SN1 and the second one SN2. Here S for substitution, N for nucleophile, and 1 means it depends on concentration of one reactant. And here S is substitution in nucleophilic, and the 2 means that depends on concentration of two reactants. Again I'm mentioning the 1 means that depends on concentration of one reactant, and the 2 means that depends on concentration of two reactants. Now see the SN1 mechanism, it has two steps. This is tertiary haloalkane. This is Br we are using. It will be broken down. This is reversible reaction, the slow reaction. Here we get carbocation plus Br minus. The second step, with haloalkane and a nucleophile. With this one, the nucleophile OH, this is the first reaction. So the product is OH. This is the tertiary alcohol, 3 degree alcohol, 3 degree haloalkane. So this reaction has two steps. The first one is slow. Slowest step is the determining step. So that depends on only the haloalkane breaking, because without making the carbocation, OH minus cannot react. So if you increase the concentration of OH minus, the overall rate of reaction won't be increased. But if you increase the concentration of the tertiary haloalkane, it will made faster, and the overall reaction will be faster. So for this reaction we can write mnemonics here. S2, 2 steps, and the tertiary favored. So SN 1 to 3 degree, you can use it. This is the mnemonics. Again I'm telling The 1 here, red depends on concentration of 1 reactant, 2 means 2 steps, and 3 degree means tertiary favored. Now SN2 mechanism. H C2H5. Here the C is partially plus and the Br is partially minus, so nucleophile will attack just opposite to the bromine, and so the product CH, this is half broken and this is half ment, OH C2H5, then Br. The overall charge is here negative. Overall charge negative because of 2 nucleophiles are here, and when the Br left, the product is OH C2H5 H, and here is H plus Br minus. So we are getting the alcohol, primary alcohol in this reaction. This is only the one step. This is transition state. Only the one step we call it. So SN1, one step, only one step, and primary favored. This is the mnemonics. So SN 2 degree, 2 means red depends on the reactant of 2 reactants. Red depends on 2 reactants, and this 1 means only one step, and the 1 degree means primary favored. We are almost in the last part of this chapter. The last point is the uses of halogenalkane. Yes, CFCs and their replacement, plastic manufacturing, and insecticides manufacturing. If you have any confusion of this chapter halogenalkane, you can write to us at Catalyst Education. Catalyst Education has face-to-face and online education platform. Thank you very much.